Hi guys, welcome to my channel Science to Scientist. I am Ritik Singh and today we are going to start our new chapter, that is atoms and molecules. Before that, I would like to present a few words of Joseph Gordon-Levitt, that the universe is not made up of atoms, it's made up of tiny stories. As your tiny stories will one day make a new universe. So now let us start with our session. The Indian divisibility by the Indian philosophers, we will first know about them. That were Maharishi Kannad and X.C. Katyaman. So now let us something know about Maharishi Kannad. He postulated that if we keep on dividing the matter, that was called early in Indian language Padarth, we will get the smaller particles, smaller and smaller particles. And soon we will achieve a point where these smallest particles will be achieved, and that will call the Parmanu, which will not be divided further. Now another man was X.C. Katyaman. He postulated that there are various forms of matter because particles of matter exist together in combinations. Now let us know something about the divisibility of idea by the Greek philosophers. Now there were two philosophers, that were Democritus and Leucippus. So they suggested that when we keep on dividing the matter, there comes a time when no more division of particles can be taken place. Such particles are called atoms, which means being indivisible. But all these ideas were not backed up by many experimental pieces of evidence until Antoine L. Lavoisier provided two laws of chemical combination. Now let us talk about the laws of chemical combination, which was provided by Antoine L. Lavoisier. That was the law of conservation of mass and the law of constant proportion, also known as law of definite proportion. So the law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction said by Lavoisier. And the second law was law of constant proportion. The elements are always present in definite proportions by mass in a chemical substance as per said by Joseph Proust. For example, hydrogen and oxygen are present in water in a ratio of 1:8. So if we decompose 9 grams of water, we will obtain 1 gram of hydrogen and 8 grams of oxygen. Now moving further to the atomic theory. John Dalton proposed an atomic theory in 1808, which acted as an explanation of the above two laws. As per the theory, all matter, whether it is an element, compound or a mixture, consists of tiny indivisible particles called atoms. The postulates of atomic theory by John Dalton were: the first, the matter is made up of tiny particles called atoms that cannot be divided. Second, atoms are never formed or destroyed during a chemical reaction. Third, atoms of an element exhibit same nature. They have the same size, mass and character. Fourth, atoms of different elements exhibit varying nature. They do not have same characteristics. Fifth, atoms form compounds by combining in ratios of whole numbers. And the sixth was, a compound contains a constant number and kinds of atoms. Now let us start about atoms. We can call atoms as the building blocks of a matter, just like bricks are the building blocks of a building. So now, what is the size of an atom? Atoms are extremely small. The size is measured in nanometers, where 1 nanometer is 1/10⁹ meters. Atomic radii is measured in nanometers. That is, 1/10⁹ is equal to 1 nanometer, and 1 meter is equal to 10⁹ nanometers. Now let us see something about relative sizes of different atoms. That is, the radii of an atom of hydrogen is 10⁻⁻10 meters. Molecule of water is 10⁻⁻9. Molecule of hemoglobin is 10⁻⁻8. Grain of a sand is 10⁻⁻4. Ant is 10⁻⁻2. And watermelon is 10⁻⁻1.
having the radii in meters.
Moving further to symbols for atoms, here are some examples of the symbols that are used to represent different atoms.
Now let us see some of the elements as proposed by Daltons. The symbol of hydrogen, carbon, oxygen, phosphorus, sulfur, iron, copper, lead, silver, gold, platina and mercury, as you can see in the figure.
The symbols for representing an atom is generated from first two letters of element's name. The first letter is always in uppercase, that is capital letter, while the second letter is written in lowercase. Here, let us see some of the examples. Now let us know about atomic mass. The Dalton atomic theory suggested that each element has a distinguishing atomic mass. With this theory, the law of constant proportion could be explained easily. But it is indeed difficult to evaluate the mass of an atom since the size of an atom is relatively small. Therefore, scientists started evaluating the mass of an atom by comparing with the mass of a standard atom. Earlier, 1/16 of the mass of an oxygen atom was used as a standard for calculating the mass of other elements. Now, carbon-12 is considered the standard atom for calculating the mass of its atomic mass is 12U, that is 12 atomic mass units. Thus, we can say that one atomic mass of unit is the mass of 1/12, the mass of carbon-12 atom or C12 atom. Here is the list of atomic masses of few elements. After knowing all about atom, I would like to ask one question. Can atom exist independently? No, atom cannot survive independently as atom joins together and form molecules or ions. Moving further to molecules, a molecule is a collection of various atoms that combine chemically with each other. These atoms are bound together by certain force of attraction. Atoms of the same elements or different elements can be bound together to form molecules. Therefore, a molecule is the smallest particle of a substance that can exist independently and shows all the properties of that substance. Now talking about molecules of elements. The molecules of an element are formed by combinations of similar types of atoms. For example, helium is made up of only one atom, while oxygen is made up of two atoms. Now what is atomicity? Atomicity, the number of atoms in a molecule of an element is called atomicity. For example, helium is a monoatomic and oxygen is a diatomic. Now what is monoatomic? When an element comprises of a single atom, it is called monoatomic, and its examples are all metals. Whereas diatomic, when an element comprises of two atoms, it is called diatomic. An example of it will be all gases which are present. Now what is triatomic? When an element comprises of three atoms, it is called triatomic. Now you might be also having doubt about tetraatomic. So tetraatomic is an element comprising of four atoms. And polyatomic, when an element comprises of more than four atoms, is called polyatomic. Now here are the few examples of atomicity of elements. Talking about molecules of compounds. Molecules of compounds constitute of atoms of different elements that combine together in fixed proportions. For example, water comprises of two atoms of hydrogen and one atom of oxygen. So let us see in few of the examples. Ions. Compounds containing metals as well as non-metals. These elements include charged species which are known as ions. Thus, ion is a particle that has a positive or negative charge. They are of two types, that is anion and cation. Anions, negatively charged ion, and cation, positively charged ions. there can be a single charged atom in an ion, or there may be a group of charged atoms in an ion that have a net charge on the compound. When a group of atoms carries a charge in a compound, it is called as polyatomic ion. Now let us know about chemical formulas. We use a chemical formula to represent the compositions of a compound in the form of symbols. To write the chemical formula, you must know two things, that is symbol of an element and second the valency. So what is a valency? It is also known as the combining capacity of an element. In other words, valency explains how atoms of one element will mix with atoms of another element. For example, the hydrogen ion is represented as H+, which means that it has valency as 1. Similarly, the oxygen ion is represented as O2, which means that it is valency is 2. Here is a list of valencies of various elements. Talking about mole concept, how do we interpret a chemical equation like 2C plus O2 give rise to 2CO2? So we say that two molecules of carbon combines with one molecule of oxygen to form two molecules of carbon dioxide. We can also say that 24U or AMU of carbon molecules combines with 32 AMU of oxygen molecule to form 56 AMU of carbon dioxide molecule. Therefore, we can characterize the quantity of a substance by its mass or by its number of molecules. A chemical equation directly indicates the number of molecules participating in the reaction. Thus, it is convenient for us to refer the number of substances in a chemical reaction as numbers of molecules or atoms. Now, defining a new SI unit, that is mole. Mole is a numerical quantity that has a mass equal to atomic or molecular mass of species, that is atoms, molecules, ions or particles. 1 mole of any substance, which is equal to 6.022 into 10 to the power 23 numbers of particles. This is called the Avogadro number or Avogadro constant, which is represented as NO. The mass of 1 mole of substance is the same as that its atomic mass or molecular mass expressed in grams. Now, what is the gram atomic mass of a substance? The atomic mass of a substance when expressed in grams is known as its gram atomic mass. Now, moving further to gram molecular mass of a substance, the molecular mass of a substance when expressed in grams is known as gram molecular mass. For example, the atomic mass of sulfur is 32 AMU. The gram atomic mass of sulfur is 32 grams. Also, 32 AMU of sulfur has one atom of sulfur. That is 32 grams of sulfur has 1 mole atom. That is 6.022 10 to the power 23 atoms of sulfur. Similarly, we can say that the gram molecular mass of carbon dioxide is 56 gram, but we know that in the case of chemical equation, mole is the measuring unit. Therefore, 1 mole equal to 6.022 into 10 to the power 23 number. Relative mass in grams. Wilhelm introduced the word mole, which actually means a heap or a pile. Therefore, we consider a substance as heap of atoms or molecules. Now consider this formula of number.
So now let us consider these formulas. Numbers of moles, which is equal to mass of substance by molar mass, or number of particles by Avogadro number. So now let's have a look on a review of how mole, Avogadro number and mass are related to each other. 1 mole of carbon is equivalent to 6.022 into 10 to the power 23 atoms of carbon, which is equivalent to 12 gram of carbon atoms. 1 mole of hydrogen atom is equal to 6.02 into 10 to the power 23 atoms of hydrogen and 1 gram of hydrogen. Whereas 1 mole of any particle, that is atom, molecule or ion, is equivalent to 6.022 into 10 to the power 23 numbers of that particle or relative mass of those particles in grams. 1 moles of molecule is 6.022 into 10 to the power 23 numbers of molecules, which is equivalent to molecular mass in grams.
By this, we have completed our today's video, Atoms and Molecules. If you like this video, please don't forget to subscribe it, share it and press the bell icon to get regular updates about the video. If you have any queries, feel free to write in the comment box. Thank you.